Hello, sir.
Okay, so today what we are going to learn about fabrication of MOSFET. Okay. So what you will know about after completion of this lecture. So you will know what are the various process steps used in fabrication of VLSI chip. Means how to fabricate the integrated circuit. And what are the different steps or different processes. And then you will know how to fabricate NMOS transistor and PMOS transistor, because once you know NMOS, then PMOS is very easy because all steps are same. Only you need to change the doping. Okay, so this is outcome. And what are the different processes? First is oxidation process we use. Then diffusion and ion implantation we use. We use lithography process. We use deposition process. We use etching process, and we use metallization process. All these fabricate or manufacture, you can say that, to manufacture integrated circuit. Okay, so how it is oxidation, you know, when you keep something, oxidation takes place. Okay, so basically oxygen reacts with that material and oxidation takes place. Diffusion or implantation means, diffusion means we are putting some impurities in some material.
Yes, sir.
Lithography is basically photograph means basically creating some patterns in stone, that is called as lithography. So we consider that silicon material, because everything is fabricated in silicon, that is called as and if you are creating circuit in that, that is called as lithography. We will see that. Deposition means we are depositing something. Etching means whichever is not required, that is etched out or removed. And metallization means finally we connect all devices together. Okay, so but first thing, everyone should know that what you are going to fabricate, because that picture should be in your mind, and you are fabricating NMOS transistor. So what is NMOS transistor? NMOS transistor start with P-type substrate, whatever I'm showing here, P-type substrate. Then there are two N plus means N-type dope, N plus heavily doped. Source and drain regions are there. Then there is a gate. Then there is a gate. Okay, you can see that gate. So this is called as polysilicon gate, which is like the metal itself. Then there is source and drain contact. And whatever you see, this filled oxide, it is called as filled oxide. It is thick, and this is used to isolate two devices from each other. Okay. This is a two-dimensional picture. That was three-dimensional, and this is two-dimensional. N plus source, N plus drain. This is P-type substrate, whatever yellow, faint yellow or light yellow you see. Then this is thick oxide. You can see here. This is thick oxide. And this is very thin oxide, which accepts gate insulator. And this, whatever you see red one, that is polysilicon. So this you have to fabricate. So how you are going to fabricate this? So I have shown various processes. So basically this is wafer. We don't fabricate single transistor. We fabricate billions of transistors, billions of transistors. So this is wafer, silicon wafer. Okay, it's a circular disc. And what that circular disc is divided into several parts. Okay, so that is used in several small squares like this. So this is one square. So this is another square, whatever you see here. And this one square is called as die. Die means one chip. So you can see in one circular disc or wafer, there are so many chips. So one integrated circuit. So and such many wafers. This is one wafer. Suppose this one wafer is how many fabricating? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe it is fabricating something 20 devices, 25. So one wafer can fabricate 25 ICs. And at a process, suppose I'm carrying out oxidation process, we put so many wafers, 25, 30 wafers. So 25 multiplied by 30. So that many integrated circuits are fabricated in one go. For example, now there is an oxidation furnace. So first step is we start with, so whatever, see, there is an oxidation furnace. And oxidation furnace, you can see here wafers, circular wafers here, here, here. You can see that. This is just side view. This is three-dimensional picture. And these are the wafers. So all wafers basically undergo the same process. Oxidation means oxidation, etching means etching, like this. And on each process, each wafer, there are so many wafers, so many ICs. So for example, I am showing the process only for single IC. You can see single IC. So I have taken just one, and it's top view basically, and cross section. So I have taken cross section here. So it is lightly doped P-type substrate. You can see lightly doped P-type substrates. So this is first step. Then oxidation is carried out. So you can see here that vapor is kept in the oxidation process. Then oxygen gas is passed over the substrate. Then it will react with the substrate. It is heated at very high temperature, like 200 degrees centigrade. And some of the surface is consumed. Some of the silicon surface is consumed. So you can see here oxide from top, and you can see from the cross section. The next process is silicon nitride. Silicon nitride is also one of the material which is deposited on silicon dioxide. You can see from top, and you can see from the cross section. Same thing.
Okay, sir.
Yeah. Then next step is photolithography, lithography. Because we have to fabricate circuit or transistor in silicon. So therefore we need to perform lithography, photography. Basically what you want to do, that is printed on thin silicon, thin glass paper or glass. So photolithography basically involves 3 steps. One is mask. You can see the mask. Mask is a thin glass plate on which patterns are printed. So this is very transparent glass plate on which that dark portion, whatever you see, that is called as active area. Okay, that is called as active area where transistor is fabricated. Then we deposit photosensitive material. Photosensitive material means it changes its chemical properties when exposed to ultraviolet radiation. If it is soft initially, it becomes hard, or if it is initially hard, then it becomes soft. So that is photosensitive material. And then development of photosensitive material. Then that photosensitive material, after exposure to ultraviolet radiation, it is developed. Means whichever is soft, that dissolves in the developing solution. Whichever is hard, it remains as it is. And this is used to fabricate your transistor. So this is something like a photolithography. So you can see here is a spinner. Okay, and now everything is automated. Yeah. So whatever is the pattern, so that pattern is basically projected on this vapor. So first we apply photosensitive material, and in order to get that uniform thickness, so this is vapor you see here, on which that photosensitive material is dropped, and this is rotated so that it gets applied uniformly. So here I have shown here. So this is your substrate at the bottom. Then this is oxide, this is nitride, and this is photosensitive material, whatever you see here. So this blue part. And this is your mask. And from top, what you can see, only mask and that photosensitive material. Then this photosensitive material is exposed to ultraviolet radiation. So when it is exposed to ultraviolet radiation, you can see it is changing its color, or it's changing its color. Why? Because it undergoes some chemical change. So initially it was hard. So you can see here it is hard. Just this dark portion below, it is hard. It will remain hard and soft. Then we will develop, next process is we will develop this photosensitive material. So when it is developed, you can see here mask is removed and this much part gets dissolved in the developing solution. Okay, and this hard photoresist will remain as it is. From the top, what you can see this silicon nitride and this portion. Now next is etching process. Etching means this whole structure is kept in etchant, and this engineer is observing what is happening through that etching process. So see here, etched away. So whatever was that exposed, so this much portion is exposed. So that is etched away in a chemical solution. But nothing will happen to the portion which is just below the oxide, this hard photosensitive material. Now see here there was a photoresist, so this much will remain. Now next step is again, this is repetition. Next step is here, oxidation is carried out. So oxide will grow here, exposed portion here and here. So that is called as field oxide. You can see here, field oxide.
Yes, sir.
Okay, field oxide. And whatever you see here, that silicon nitride, that is basically where transistor is fabricated. Right?
Yes,
so then that silicon nitride is removed. So from the top, so you can see this is the silicon area. And other transistor may come here, this side also. Other transistor may come this side also, right? But they are isolated by this thick oxide. Now, next step is this thin oxide is grown. Thin oxide. You can see here, thin oxide, very thin. So thick is field oxide. This is gate insulator. Then on which polysilicon is deposited. You can consider this polysilicon like a metal. Okay.
Yes.
So that metal is deposited. And then photolithography process is carried out. Then we are using mask number 2. Its pattern is like this. Okay, this is mask number 2. So what is this?
Yes.
This is gate mask. It creates the gate.
Yes.
Okay. Then this is photoresist. This is mask. This is polysilicon material. Then this is exposed to ultraviolet radiation. So when you expose to ultraviolet radiation, only this much pattern will change. Exposed pattern will become soft. Okay. Earlier it was dark. Now it becomes soft. So then this is developed in a developing solution. So what happens? Whatever was that exposed part, so that dissolves. But now this whole structure is kept in developing solution. So what happens? That etching solution. So whatever is this exposed polysilicon, that dissolves. This much part of polysilicon dissolves in the developing solution, and nothing will happen to the polysilicon just below this photoresist. Can you see here?
Yes.
Yeah. So from the top, this is photoresist. Below that, there is a polysilicon. You can consider that as a metal. Then in next step, that polysilicon, this is removed. So when you remove this, you will get this type of gate. So this is called as gate of the MOSFET. In cross section, you can see only this much part, this much. But backside there is a. Now what we have substrate, we have gate insulator, we have gate. Now what you need N plus source and N plus drain now.
Yes.
So N plus drain and N plus source is obtained by ion implantation process. So this is ion implanter. You can see a very big machine. Ion implanter means this is used to impart impurities in silicon selectively. So now this is implant, you can say. and that N plus implant is made, N plus impurities. So that N plus impurities will penetrate through this thin oxide here. You can see.
Okay.
And it will penetrate through thin oxide and forms N plus source and N plus drain in P-type material. Okay. And that N plus impurities will be received by this polysilicon material also. But it will increase the conductivity. But this N plus impurities cannot penetrate through this thick oxide. This thick oxide blocks this N plus impurities. Okay. So thus,
Yes, sir.
for gate, you have N plus source, N plus drain, gate, insulator, and gate. Now what you have to do, you have to take the contacts, source, drain, gate. Then what we do, everywhere insulating.
Yes, sir.
Hello, Glenn, are you there?
Yes.
So material is deposited everywhere, insulating material, because we have to take the contacts. Then contact mask. So this is another mask, contact mask, which creates the window, because we have to take the contact to substrate, source, drain. So this is to make the windows. So then after photolithography, you can see here that windows are created by all process, photolithography, exposure to ultraviolet radiation. Okay, then this is substrate, and this is from back side. See, you cannot see the contact in gate contact in front, because we are taking cross section here. Okay, so back side is gate contact here, whatever you see, pink. Then metal is deposited everywhere. So you can see here, metal is deposited everywhere. Okay. Then now in this case, everything is shorted. You can see everything is shorted. Source, drain, everything is shorted. So we need to separate out. So unwanted metal is removed by etching process. So for that we use mask number 4, and that is called as metallization mask. Okay, these are the metallization.
Then it's not separated.
Yeah, then unwanted metal is removed, and you have only this is gate contact, source contact, substrate contact, and drain contact. So in this way, then if you, this is fabrication of MOSFET, and if you see, this is active mask, cusp mask, this is gate mask, this is contact mask, and this is metallization mask. So if all masks are aligned together, then whatever is, this is called as layout of MOSFET. Okay. Active mask, then gate mask, then contact mask, black, whatever you see.
Like on one wafer.
Yeah, there is an alignment. So when you put all masks together, so this is called as layout of the MOSFET. And this width of the active mask decides width of the transistor, and width of this polysilicon mask or gate mask decides length of the transistor. Okay. So in this way, we start with NMOS fabrication. Now PMOS fabrication, so this is layout of inverter. So this is just layout of transistor. This is layout of inverter. So this is PMOS transistor, this is NMOS transistor, this is output, these are drains, like that. Okay. So this is VCC, this is ground. And this is just 2 transistors, but if there are millions of transistors, so your layout will look like this. Okay. So this is layout of one processor. And this layout is basically given to industry, then industry will fabricate it.
Okay, sir.
Okay. So this is fabrication of PMOS transistor. Okay. So this is lightly doped N-type substrate. So everything is same for PMOS. Only in case of P-type substrate, we start with N-type substrate. Okay. This is N-type substrate. That's why I have changed the color. Then again oxide is deposited. Silicon nitride is deposited. Same.
Same thing.
Then gate mask is used.
Yeah.
Then this is photolithography process. Again gate mask. And see here, exposure to ultraviolet radiation, then development and etching process. Okay, so everything is same. So this is now where NMOS transistor, PMOS transistor is fabricated, active area. So this is result of active area mask, first mask. Then we deposit thin silicon dioxide. You can see here.
Yes, sir.
Then polysilicon is deposited. Then mask number 2, that is gate mask, is used. Okay. Then
Yes, sir.
exposure to ultraviolet radiation, and unwanted polysilicon is removed. This polysilicon is removed. See here. Now what you see, only this photoresist. When you remove that, then you can see that polysilicon. That is, you can call that as like a metal.
Yes.
Then N plus source, ion implanter. Again, ion implanter is
Ions.
yeah, ion implanter. Now
Then
P plus impurities are
P plus impurities will come.
So this is P plus.
Yes,
P plus source, P plus drain, and this is N type substrate. Okay. Then
okay.
Insulating material is deposited everywhere. Contact mask is used. This is mask number 3, right? And contacts are made. So you can see here source contact, drain contact. This is substrate contact, and this is gate contact. Then metal is deposited, right? Then everywhere metal is removed. Okay, everywhere metal is removed. Means unwanted metal is removed. So when you remove unwanted metal, this is a drain, this is source, this is substrate. Yeah. And in this way, your PMOS transistor is fabricated. Everything is same. Only wherever there is N, you have to make P, and wherever there is P, you have to make N. Okay, so this is layout of the IC, same. So active area mass I have shown here. Okay, so in this way, NMOS and PMOS transistors are fabricated. So there are various steps, various processes: oxidation, lithography, etching, photo deposition, ion implantation, and by applying all these processes, we create NMOS transistor and PMOS transistor. So you understood this flow?
Yes, sir.
Just go through the slides.
Yeah.
Then in next lecture, what we are going to do is we will go through CMOS, means how to fabricate NMOS and PMOS transistors simultaneously. That is CMOS circuit. Okay. So that we will see at what time? 3 o'clock, na, today?
3. Yes, sir. 3 o'clock.
Okay.
Yes, sir.
Then we will stop here, and 3 o'clock we will meet again. It's okay?
Okay, sir.
Fine?
Okay, sir. Thank you, sir. Yes, sir. Thank you, sir.